All right. Good morning, everybody. I hope you got a nice rest over the weekend after a very long midterms week. I want to say congratulations to all of you for making it through. As I've been looking through our midterm in Algebra 2, I've been super impressed not only by the results, but also by some of the creativity that a lot of you used in those distinguished problems. We're going to look at that a little bit more on Wednesday. I should be back for then. For today, please be kind to your substitute. I've got this video to help you along. You really only have two things to do today. The first thing that I want you to do is go back to Google Classroom and fill out a survey that I've linked there, just asking you about what your math course plans are for next year. So those of you who are not seniors, you are probably taking another math course if you don't already have your 4 credits. So just fill that out. I'd like to know kind of where everybody is heading, so that myself and Mr. Wall can kind of make plans about what stuff we do have to cover, what stuff we don't have to cover for the rest of the year. So please pause the video, go take that survey right now. All right, thank you for taking that survey. So today we're just going to talk about how to find zeros in Vertex form. Okay, so let's take a look at the 3 forms we've been working with. The first one was intercept form. When we were finding our zeros, we were kind of using that as another name for those x-intercepts. So intercept form we found was the easiest one. In intercept form, all we did was identify that the x-intercepts existed at P and Q. So we were able to just kind of take those variables right from there, and we've got what we're looking for. From there, we worked with standard form. This is kind of what we've just been doing with the factoring. So we said, hey, we can take standard form, and in most cases, we can factor it into intercept form just by looking at how to write it like this, or something like this. We had different variations that we looked at, but essentially we're asking ourselves, well, hey, what multiplies to C and adds to B? And we kind of chose some numbers that went in those spots. So far we have a really good way to find our zeros when we have a quadratic in intercept form and when we have a quadratic in standard form. The last thing we need to look at is, well, what if we have a quadratic in Vertex form? We haven't really talked too much about this. Well, one of the things that we did work on a little bit was converting this to standard form. And then I guess from standard form, we could convert it to intercept form if the numbers worked out nicely, and we could get there kind of circuitously, kind of going around the track. But there is a much better way. And I just want to point out some important things that we're talking about. When we're talking about our zeros, we are talking about those x-intercepts. So we're talking about those 2 points. And as we have said many, many times now, those 2 points exist. The things that any x-intercept have in common is that the y is 0 for them. The y is 0. This is the key to unlocking so much of this stuff. So if we say, well, hey, we know that for our x-intercepts, that's going to be 0, we can rewrite this vertex form and try and solve for an x value or x values that would make our output 0, that would make y equal to 0. So let's look at some examples of how we do this. So here is one of 2 worksheets that you should have. I believe this one, Mr. Wall helped us print on green paper. It should have A, B, C, D, E, and F. These are the examples I'm going to work through in this video. And then there is another worksheet that goes with it where you will have some practice problems. I believe it's 1 through 9. So I'm going to talk about some examples. After each example, I'm going to ask you to pause the video and then go find a couple examples from the white worksheet. It's titled Finding Zeros of Vertex Form number 1. So at the very top, this is saying, what do we mean by finding zeros? And all we're really talking about when we find zeros, again, all we're really talking about is finding some x values. So finding x values that will result in y equal to 0. Okay, we're going to have some input values. These are inputs, remember, that are going to have an output of 0. And that's where the function is going to cross that x-axis. So that's what we're talking about when we're finding zeros. It really is just another way to talk about finding our x-intercepts. So how do we do this? How are we going to do this? We have our function form for Vertex. Looks very much like this. If we have some numbers in there, what we're going to be trying to do is we're going to be trying to solve for x. So the first thing that we're going to do is set y equal to 0. The second thing we're going to do is solve for x. Now, how do we do that? We go reverse order of operations. We're essentially trying to undo everything that has happened to x to get it by itself. So if you remember, we talked a little bit about Gemma. There's a poster on the wall. You might also previously have in your brain PEMDAS, and that's fine too. Gemma was grouping, exponents, multiplication and division, and addition. And so for this process, we're actually going to go backwards because we're undoing what's happened. So let's look at A. Let's kind of see what's going on here. That was the first thing we said we were going to do. We were going to set this equal to 0 because we're trying to find where y equals 0. Now, from there, I'm going to go in reverse order of operations. So actually, the first thing, if we looked back up here, the first thing that we're going to do is any addition and subtraction. We're going to undo that. So back over here, I'm actually going to add 4 to both sides. I'm trying to get x by itself. So I get 4 over here, and I have x minus 3 squared over here. The next thing I would do would normally be multiplication and division. I don't see any here. So working backwards, I hit exponents. So I've got this little exponent on my group that I'm going to have to undo. If you don't remember, how we undo a square or an exponent is by rooting or square rooting in this case. So we're actually going to square root both sides. So we're going to find the square root of 4. And then we're going to square root everything on this side. So we're going to put everything that was on this side under the root bracket like that. So on this side, we know that the square root of 4 is 2. And that can be a positive or a negative 2. So we actually have two numbers that we're working with here. We have a positive 2 and a negative 2. This is critical. This is kind of the big piece of the puzzle. Now, what happens over here? The square root of a square, those cancel each other out. Those are opposite, opposing operations. So what we have left is just the x minus 3 from inside there. And in fact, because nothing's happening to it anymore, we can get rid of these parentheses. There's nothing really going on outside of that group anymore. So this is where it gets a little bit tricky. The next step, I think most of us could probably pick out, is we're going to add 3 to both sides. I think that's a smart thing to do because those 3's will go away and we'll have x by itself. However, it's really important that we remember when we took that square root, we had a positive and a negative 2. So we actually have two numbers that we're working with. So we have the positive 2 that we're going to add 3 to. We also have the negative 2 that we have to look at that we're going to add 3 to. And then, of course, on the other side, we just have x left. We just have this x left. So x can be either positive 2 plus 3 or negative 2 plus 3. And what would those be? Let's see. Positive 2 plus 3 is 5. Negative 2 plus 3 is 1. And so those right there are our x-intercepts. This kind of lines up with what we've been seeing. We've been seeing 2 of them. That's what we would expect in most cases, is that we would see 2 x-intercepts. And this one actually happens at 5, and 0. If we were going to write those as ordered points, or an ordered pair, we would write 5, 0, and 1, 0. Remember, that's that x and that's that y. That's how we write our ordered pairs. And if we were ever curious, if we came up with two numbers and we were saying, well, I'm not super confident in my work, we can always take those back up into the original equation. So a good way to check your work is just to say, well, I'm going to check my work here. I'm going to change my color just so we can see that this is the checking work portion. I've got this function where if I plug in an x, I'm going to get that minus 3 squared minus 4. So let's try it out with 5. Let's see if x is 5, what's going to happen here. 5 minus 3, well, that's 2. 2 squared is 4. And well, hey, look at that. 4 minus 4 is 0, so we're happy with that one. Let's try it with 1. If x was 1, let's see what happens. We got 1 minus 3 squared minus 4. 1 minus 3 is just negative 2 squared minus 4. You can probably see already what's going to happen. Negative 2 squared is positive 4. And yes, that one comes out to 0 too. So we're super happy with these zeros right there. Awesome. What I'd like for you to do is pause this video, go to the other worksheet, the Finding Zeros of Vertex form number 1, and find at least one problem that looks like this and try it out right now. So pause the video, go do that. Okay, welcome back. Hopefully you found one and felt pretty good about it. We're going to look at B next. I want you to notice the difference between A and B. The difference here is that notice here in A, we have nothing here, or we've sometimes talked about that as A equals 1. That's the situation here. Well, over here, we've got something else going on. We've got A equals 3. So we need to think about what this changes. Let's go through this process again. Setting it equal to 0. And then we're going to work backwards through the order of operations. I'm going to add 48 to both sides. I'll have 48 equals 3 times x plus 5 squared. Now, the difference here is that in the last one, we didn't have any multiplication or division to undo from Gemma. But now we do. We have this 3 that we have to divide out. So I'm going to divide both sides by 3. Just like that. Those 3's will go away, and we have x plus 5 squared over here. And if we do 48 divided by 3, that is 16. Now we need to get rid of the exponent, so we're going to do square root of 16 equals the square root of x plus 5 squared, like that. We get positive and negative 4, and we just get the x plus 5 from inside. Our next step would be to minus 5 from both sides, and this is again where we have to remember we've actually got two numbers that we're working with here. So we have positive 4 minus 5 equals x, and we have negative 4 minus 5 equals x. 4 minus 5 is a negative 1. Negative 4 minus negative 5, we're going more into the negatives, that is negative 9. So those are our x-intercepts. Again, as ordered pairs, we might write this as negative 1, 0, and negative 9, 0. Perfect. Again, pause the video, go find at least one on the handout that looks like this, something where the a is a positive integer, so something like 3, 4, 5, something to that effect. So go do one, pause this video, and come back. All right, welcome back. We're going to look at another one. We're going to look at C now, and we're going to think about what is different here. What's different here is that, yes, this is not 1, but it's also not a positive. We have a equals a negative 2. It only changes things very slightly. So quick work through this one. We've got 0 equals negative 2, x minus 7 squared plus 18. Again, we're setting it to 0 because we're finding where y equals 0, where the output is 0. We're just going to kind of go through our undoing process. So minus 18, we get negative 18 over here equals negative 2 times x minus 7 squared. We're going to divide off that negative 2. And here we have a negative 18 divided by a negative 2. So I know 18 divided by 2 is 9, and a negative divided by a negative is a positive. Those cancel out, and I've just got x minus 7 squared over here. Square root to undo the square on the right-hand side. Those cancel out, and we get positive and negative 3, and x minus 7 over here. We would add 7 to both sides. And again, we're working with two numbers. So we have 3 plus 7 equals x, and we have negative 3 plus 7 equals x. So let's see, 3 plus 7 is 10, and negative 3 plus 7 is 4. So there are our intercepts. And again, as ordered pairs, we have 10, 0, and 4, 0. All right, same routine. You're going to go find one on the other worksheet that has a negative integer for a. So you're going to find something that looks like that and come back. Awesome. Hopefully that wasn't too bad. It's not much different. This one might give you pause, but I promise it is not that bad. Notice here the difference. The difference is now that a is not an integer. A is some sort of rational number, a fraction or a decimal. So a equals, in this case, a positive rational number. But the process is exactly the same. We're going to set it to 0 because we're looking for those intercepts. And we're going to just start undoing everything. So to get rid of this minus 18, we're going to add 18 to both sides. We get 18 equals 1/2 times x plus 4 squared. Now, we want to get rid of this 1/2 here. And I want us to be like kind of just remembering what it means to quote unquote get rid of. We're not bringing this to 0, we're bringing this to 1. Whenever we had an integer there, when we had up here, when we had the 3 here, when we divided by 3, right, let me get my own pointer out. We divided by 3 right here. We said 3 divided by 3. We kind of cross those out. What we're really leaving behind is 1. We're leaving behind a 1 right there. It's really 1 times that. And because we don't really write 1 times something, we just leave it out. So remember, we're not really trying to, when we say we're getting rid of something, we're not trying to bring it to 0. We're trying to make it 1. So here we have a couple of options. It kind of depends on how we see fractions. We all see it a little bit differently. Some people right here would say, well, it's a half, and I know I just kind of divide by that number, so I can divide by 1/2 on both sides. You totally can. However, I would caution people to really be careful when you're thinking about this. 18 divided by 1/2 is not 9. 18 times 1/2 is 9. And I think sometimes we see this 18 divided by 1/2 or some number divided by 1/2, and we think we're just taking half of it, but we're not. It's dividing by 1/2. So we're actually asking how many times does 1/2 go into 18? That's what we do when we divide. If you're a decimal thinker, you can also think about this as 0.5. 1/2 and 0.5 are the same. And I want to push us to also think about 1/2 times 2. If we multiply 1/2 by 2, we are left with 1 right there. We would have a 1 exactly where we need it. So we could also multiply both sides by 2. So we think about 18 times 2. No matter how you think about it, we're going to come out with 36 equals just the 1 x plus 4 squared. And then we do our normal stuff. Square root both sides to get rid of the exponent. those will cancel out. We get plus or minus 6. And we got x plus 4 over here. We're going to minus 4 from both sides. And again, we're working with two numbers here. So we just got 6 minus 4 and minus 6 minus 4. And those are going to be equal to just x. So x is 2 or negative 10 here. Writing those as ordered pairs, we would have 2, 0, and negative 10, 0. Okay, same old song and dance. You're going to go find a practice problem from the other worksheet that has a positive fraction for a positive rational number. Get that done and come on back. All right, hopefully that was not too bad. You can probably see exactly what's happening now. You're starting to pick up on the patterns, I bet. Well, we're going to look at a negative 1/3. Nothing else here is different, just a negative 1/3. Really, really kind of covering all of our bases here. So we're going to set this to 0, because we're finding those intercepts, and we're just going to kind of undo all the steps. We're going to subtract 27. So we get negative 27 equals negative 1/3 times x minus 6 squared. Here we have the option of dividing by negative 1/3, or we could multiply by negative 3. Both of those options would get our a value to be a 1 here. We'll basically get rid of, quote unquote, that negative 1/3. I'm going to times by negative 3. I like to work with integers better than fractions. So let's see, what do we get? 27 times 3. 27 times 3. If you don't know right away, that is 81. If you ever had to double check, remember, stack multiplication never fails us. 3 times 7 is 21. 3 times 2 is 6, plus that 2 up there is 81. There it is. And because we had a negative times a negative, that is a positive. We got rid of that, and we have x minus 6 squared. We're going to square root both sides to get rid of that exponent. Boom, just like that. We get positive and negative 9 as our roots there. Then we have x minus 6 over here. We add 6 to both sides, working with two numbers. So we have 9 plus 6 equals x, or negative 9 plus 6 equals x. So what does that come out to be? Let's see, 9 plus 6 is 15, and negative 9 plus 6 is negative 3. Those are our intercepts. And as ordered pairs, we would write it as 15, 0, and negative 3, 0. All right, same thing. You should have everything you need to finish off that worksheet. So pause this video, go work on finishing that worksheet, and then I'll come back. I'll ask you to come back here just for one last thing to look at. There's no examples or practice problems for it. I just want you to see one more case, which is just situation F. All right, if you are back here and class is still going, you are absolutely crushing it today. I want to thank you for your hard work. And I just kind of want to put this in your brain before you leave. Here is example F. We're going to go through our kind of normal process, set it to 0, and undo everything. So here we would add 10 to both sides. We'd get 10 equals x plus 11 squared. Your brain might be starting to say, whoa, wait a minute, something's not quite right here. We're going to square root both sides to get rid of the exponent, to undo it. So those go away. We get x plus 11 over here. And we just have this square root of 10. Well, what in the heck is that? We know we're going to get a positive and a negative root, but 10 is not a perfect square. If it was the square root of 9, sure, we know that that goes to positive negative 3. And the square root of 16 goes to positive negative 4. So that square root of 10 is going to be kind of like somewhere between 3 and 4. It's going to be some nasty long decimal. It's probably going to be closer to 3 than 4. So this is a point where you could put this into your calculator if you'd like. You'll get some nasty decimal and you could round off. That's fine. But to be more exact, oftentimes if we have something like this, we leave it just as the plus minus square root of 10. We call it a radical. We just kind of leave it like that. If we wanted to round off our process, we would subtract 11 from both sides, and we would get positive square root of 10 minus 11 equals x, and the negative square root of 10 minus 11 equals x. Certainly you could put this in your calculator and figure it out. If you do that, you'll see that they're roughly around, I think it was negative 7.84, and roughly around negative 14.16, something like that. And those would be your x-intercepts. Now these would be really hard to put on a graph because this decimal would basically go on forever and we could never get the exact point on there. We could roughly graph it, and that would be exactly what we would do here. Okay. Thank you guys for your hard work. I will see you on Wednesday. If you didn't get to finish this sheet, it is homework for Wednesday, so please finish up that Finding Zeros of Vertex form number 1. That's going to be your first habit of work grade for the new semester. Awesome. We'll see you on Wednesday. Thanks, guys. Bye.